In my YouTube handle, I have the 3 letters PhD. And you may have been wondering, what is it that I did my PhD in? You may have guessed it was something like computer science or something very similar, but actually it wasn't. I did astrophysics. And more specifically, it was computational cosmology. That is quite far from AI. However, somewhere along that journey, I found out about AI and have been diving in ever since, as you can tell from the channel. But let's look at something that I did recently. So I did a PhD. It was almost 15 years ago that it was published. And I haven't really looked at it since. But recently I thought maybe I could use Claude or other models to look at my thesis and try to find any problems that I had, or perhaps even to fix the problems that I had. What would it find if it was to look at the text? Would it find problems? Or what if it was to write some code? Could it do that? How would it be? I had some of these questions, and so I thought, why don't I just try to do this? And so I did. And this is the first part of the story. This is me talking about reviewing my thesis. So reviewing text, not reviewing code. That's going to be part 2. And here is basically what I did. So my topic, which was Schrödinger, wave mechanics, and large-scale structure. It probably should be Schrödinger or something similar. The Germans would say it obviously in a better way than I would. But that's the title. So what is that exactly? On the right hand side, you can see something which looks kind of almost like random patterns. The top part is from surveys. So this is actual astronomical data. And I believe each point is basically a galaxy. So this is real data. These are real galaxies as best as I remember. It has been a while. And you'll see that there's particular patterns. It's random, but it's not completely like disorganized random, shall we say. There is some sort of pattern to it, a structure, as we call it, large-scale structure. In the bottom, we have red, and the red is from simulations. So this was the Millennium simulation, which was 2006. But each of these sort of dots, they're particles within the simulation, they are cold dark matter clumps of mass. They're not actually galaxies. However, if you have enough of these clumps of cold dark matter together in the same place, then you might say this is statistically a galaxy. So what I did is I used a different type of formalism, not the n-body formalism. N-body formalism is where you have a whole bunch of particles in a box. These are the n-bodies. And what I did was something with the Schrödinger equation, which you may have heard of or you will know of from quantum mechanics. So the two don't seem like they would really match because you're looking at completely different scales. One is about quantum and one is about sort of very large scale gravity. And there is some interesting overlap there. On the one hand, you can consider each of these dark matter particles to be some sort of quantum particle, so there's quantum effects at large scales. I'm not sure that that's actually true, to be honest, but it's an interesting thought experiment. Or you can look at it as a pragmatic way to try to model the particles. Or in the case of wave mechanics, you actually have a field, a continuous field, it's not particles. And so you have something which is not really quantum, it's actually classical, but we're going to use those equations anyway. That's the tone. It may sound completely weird, wild, abstract to you. I don't know, it's difficult to tell what level the audience will be at, but let me take you through the journey of what I did. The PDF of the thesis is 250 pages. It's 7 chapters, it's a lot of equations, and it's a lot. It was actually more than Claude thought that it could process within its context window. It did a remarkably good job of reading it in one pass, and then we split that up into smaller files. Sometime after starting, I actually found the original LaTeX file, which is one big giant LaTeX file. if you've been in science and academia, you probably know of this sort of markup language called LaTeX, or looks like LaTeX. And it's just great for doing equations, which is why we use it. So the source file was found, and Claude read through it. I also had GPT 5.4. Both of these were in the high mode, so 4.6 Opus in high reasoning and 5.4 high, maybe even extra high, looking at each of the chapters of my thesis in order to find problems. And as best as I know, they haven't seen my thesis before, but there is also a chance that they were trained on my thesis in the past. It is a public document. It does sit on the university's web server somewhere. However, as I said, these LLMs will have seen this sort of work before in whatever published articles are. It does have some knowledge of this formalism. Now, let me tell you about the tools here, right? So this is what I'm trying to do. I want it to review the text, and I want to see how well it can do it. And I think it did actually do it well. So my preferred IDE was Windsurf. That's a VS Code fork. It's where I like to open files and have a look, and where I work. As I say, it's good. I'm actually using the Claude Code extension in that. So I have a subscription now with Claude Code with Anthropic, and I'm using that through. So Claude Code can access the files, it can read them, it can write to them, it could compile the LaTeX files, or it could compile code, of course, which is all of it should be familiar to you if you've ever used one of these coding agents. There is Git integration. It can create the commits and it can push to GitHub with my authorization, of course. And similarly, I also use the Codex extension inside of Windsurf. It's a VS Code extension. It's the same thing, right? And also Git and GitHub, as you would have guessed by now. So let's talk about the process. This is where Claude is doing science. So Claude was the main model that I was using in order to do the processing of the edits. So the review was from two LLMs, as I mentioned. They produced two different lists of findings, and then I used Claude to do the reconciliation, which means combining the lists, removing duplicates, and then looking at if one had more detail than the other, trying to merge them together and preserving the most amount of detail. Claude actually had the most amount of detail for each of the findings. Codex was good. It found a lot of things, even found things that Claude missed. In fact, the overlap was reasonably good, but not perfect overlap. The two of them did find slightly different things, which is both concerning, but at the same time understandable. Neither is perfect. I found that in the outputs from Codex, it was a bit too concise. It said the right answer, but it didn't give much details. It felt that it was almost towards like the lazier side, such that the overall outputs were shorter. And that's where Claude was a bit more verbose. And I just preferred how Claude was, how the outputs from Claude were written. From there, from these lists, so that would be 7 lists of findings, I then created checklists per chapter, and this is in Markdown. There isn't much difference between a list of findings and a checklist. However, with a checklist, what you do is you want to mark off each finding as you go, as you would probably guess from the name. And this is really important because you want to track the progress of where you are and what you have done, and therefore what you have still got to do. You can also include comments, as Claude did, as you go. I have fixed this, here's what I did to fix it. It's just small comments, but it actually helps. In addition, a big part of it was also the tracking. So using GitHub to track the differences in the documents, and so this is the version control. Once the checklists were created, they were pushed to GitHub, and that was kind of like the starting point. And from there, each time we modified a document, GitHub would keep a track of those documents, and I was making commits after each checklist was finished and then pushing that, as you might expect. And this was a great way to work. This is what really made it like methodical and more towards like deterministic. You have a list of findings, you can mark them off, and as you mark them off, you can keep track of the progress. And that's really what science is about. So if you were thinking of, oh, how does an LLM do science, that can't really do that. Well, we still have a human in the loop. It's not some completely autonomous process, although it probably could do a fair amount of what we did by itself. I wanted to be involved in order to check what it was throwing up, because there was a couple of cases where I pushed back and I said, okay, let's do this differently because I have a different opinion. So the process was working through the checklists, human in the loop, going step by step, and then just pushing those changes to GitHub. The findings, well, some of them were simple things like typos. That's not really so unexpected. And it's nice that it can find typos. You don't even need to have an LLM to find typos. You could probably do it in a better way with something like what you'd have in Microsoft Word or in Gmail or in whatever sort of app, Grammarly or whatever, right? They will find typos. Duplicate words, again, also quite easy. Hopefully these have all been found out and removed. Ones which get a little bit harder, things like sign convention inconsistency. So where I've used a minus sign or a plus sign when I should have used the other one, the LLMs have found that. That finding of sign convention is not what you could really do. I would argue possibly not with something like a spell checker. You could probably go into some nuanced arguments there. Maybe this should be like a medium. Missing cross references between chapters, again, they're probably more like a medium rather than an easy. And that's where some of my chapters ended rather abruptly and they didn't reference forward well enough. There wasn't a good linking text. Now, given that my PhD was written entirely by me, so entirely by a human, and I am obviously flawed, my text is just not going to be perfect. I've tried my best in order to make sure that the chapters were linking together, but obviously it's just not going to be like that. In it, the Claude and also GPT 5.4, they found places where my text could have been better, where I could have worded it better, where I could have added more emphasis, where I could have explained it better. And that's not really a surprise. So I'm okay with that. The harder ones are where there's like a deeper review of the meaning. If I've said something which is maybe a little bit either naive or perhaps plain wrong, then it's nice that the LLMs could flag that up. And there was a few places where I said something thinking that it was correct, something that I've maybe read in a textbook, maybe I've even checked with a couple of textbooks, and I've just misunderstood something or I didn't think it through deeply enough. And so when I've typed it into my thesis, I thought it was basically correct. And in the review process of a PhD, as you have with any PhD, you have human examiners who review your PhD. They review the text, and obviously they had also missed it as well. And it's interesting that with the benefit of an LLM, which basically has all of this memory and it has some amount of determinism, it's not fully random, it was able to find these. It was able to review the text, and it was able to make suggestions of how to fix it. And that's something that humans obviously can do, but I think LLMs are probably that bit better. Yes, it's seen some of this sort of text before, it's seen this topic before, but it's starting to outperform humans on these types of situations. The interesting one at the end was a substantial review of the very final chapter of my thesis, where I wrote some text which was interesting, which was an extension to my work. However, it wasn't considered part of my formal thesis because the examiner didn't want to examine it. It's basically the short version of the story. I'll put that in a nice way. It was a big chapter. It's very heavy going, and it was essentially not fair on him to review this huge extra chapter. And I can understand that. However, LLMs, they were happy to read it, they were happy to make suggestions, they were happy to fix the text, they were happy to even review the maths. And I think most of the maths was right, which is a surprise for me, because I wasn't sure. This is a really new territory for me, and I got most of it right. And the LLMs were able to say that, and they were able to make suggestions to where I could make it better. It looked at a model that I proposed, and it was able to suggest a way to make the model better. Should that be a surprise? It was something of a surprise for me how deep it could go into maths and sort of fairly esoteric parts of physics, and make those recommendations. Obviously, it must be in the training data somewhere, but it is there. And that was a surprise, but it's a pleasant surprise. It's one that's, while being a surprise, I can still think about it afterwards, and I can articulate why it is there and why it can be true. Challenges. So there were places where there were stylistic disagreements, where I thought that my text was pretty good, or the importance of a particular passage was good or relevant, and an AI was not so keen. I was able to push back and then reason with the LLM about why certain text should or shouldn't be there. And it was fine. We got there and we managed to include all of the things I wanted and fix up all of the things where I had made mistakes. There was a few potential false positives. These were things which the LLMs had flagged up as things which could be fixed, but not necessarily the biggest problems. During the review, the reconciliation, and even actually going through making the fixes, there were times that Claude said, you know what, this is basically fixed. Let's not worry about it. Let's just move on, which is kind of interesting to see. At the bottom, I've said about 30% of these findings were basically just kind of like ignored. It's like, we don't actually need to fix this. As I mentioned, the two models flagged up slightly different things. And that is a challenge, because you want to know, did you cover every single problem? And you can't really know. You could try to run it again and again, use different models, go over it with a human eye. But as I said, humans even missed mistakes I had made. They didn't find it, and yet LLMs did. So where an LLM is flawed, humans are also flawed. And I think, again, this is at the point where we're seeing LLMs are just starting to get better than humans at a variety of tasks. So the result is there was 7 fully updated texts, LaTeX files. That's the 7 chapters. They're all in GitHub now. You can find them. They're public. You can find the original versions. You can find the results, the checklists, the reconciled findings, and then the finished chapters. I don't think I've put them into PDF, but whatever. The bulk of the wording, so the bulk of what I said, is still preserved. So most of the things I wrote were basically true at that time. There was weak wording, which was fixed. There was new sentences added. There was paragraphs that were added, better linking text, such everything was just overall more coherent. Should we expect it to be perfect? No, we shouldn't. Will there still be mistakes? There probably is, but by and large, as things go, it's going to be in a better place now than what it was about a week or two ago. And of course, as I said, equations were updated where necessary. So that's the overall result from just updating the thesis alone, and I think that was a big win. Key takeaways. AI can do meaningful scientific review. It's not just proofreading, but it's deeper than that. It's not just finding typos or sort of grammatical mistakes, but deeper problems within text, but how it's worded and the meaning of it. Having 2 independent models helped rather than just one. Again, not perfect, but certainly better than just a single model. A structured process is absolutely necessary. Checklists, independent passes, reconciliation, being methodical through your fixes, having a human in the loop for now. I don't know when that will change, but certainly right now it's, I think, still necessary. In the next video, I'm going to talk about code, and there was a lot of interesting things that came up in doing a rewrite of the code. We discovered an old bug. We found actually why my code didn't work in the past, and we have it working now, which was great. And then we could do a new simulation and check the results, and things are very encouraging, I should say. The total time for this was days rather than months or even years. In the case of writing my thesis, it was written over. Most of the time that I was actually doing my PhD, I would write some code and write some of the thesis at the same time and keep it going. Rather than leaving the thesis writing until the very end and rush it, I actually did it somewhat in tandem all the way through. But this whole process here, doing it with Claude, it was within days, and I wasn't even pushing it the hardest that I could. It's something I was doing on the side while doing other things. And it was incredibly fast. You might wonder, well, how's it going to be whenever you touch a completely new topic? And yeah, that's where AI can struggle. If it's not within its training data, then yes, it will struggle. That's kind of how it is. But I think it could still be helpful. That's this video done. Thanks for watching it. I hope this was interesting. It's something a little bit different from what I've done so far. This is a new topic. It's not about writing apps really. It was about science, about cosmology. This is what my background is. It's something that I probably know better than AI. At least that used to be true. So if you enjoy this content, if you enjoy reading, hearing about AI and science, AI and physics, cosmology, then I may try to do some more videos. I know that I have one more video about coding. I don't know how it'll be going forward, but it's something I would like to somehow return to if possible. So like and subscribe would be helpful. Comments would definitely be appreciated. If you go to GitHub, you can put some stars on the repos, also fully appreciated. The links will be below if you're curious, if you want to check it out. I would encourage you to do so. Thanks for watching, and I'll see you in the next video.